The problem states that heat is added to a mass of ice at negative 10 degrees, converting that mass of ice eventually to steam at a temperature of positive 110 degrees, and asks us to describe the effects of the added heat at each step along the way. The first thing that must happen in this process is the temperature of the ice needs to be raised from negative 10 degrees to 0, the temperature at which solid ice can be converted to liquid water. So graphically, we can draw a short line down here showing on the horizontal axis, the x-axis, we have added heat, and on the vertical axis, we have temperature. What we see here is that initially, as heat is added to our mass of ice, that ice warms up from negative 10 degrees to 0. Once we have ice at 0 degrees, if additional heat is added, it won't raise the temperature of the ice, but instead will convert solid ice into liquid water. Graphically, we can show a horizontal line, which indicates that while heat is being added to the substance, its temperature isn't rising. What the graph can't show is that the state of matter is changing. A solid is being converted to a liquid. So at this point on the graph, this 0 degree stuff is all solid. And at this point on the graph, it is all liquid. Now that we have liquid water at 0 degrees, added heat will once again increase its temperature. In fact, the temperature of the water will rise all the way from 0 degrees to 100. At this point, the liquid water can no longer be heated up as a liquid, but instead added heat will turn the liquid into a gas. So once again, we'll have a horizontal line which indicates that the liquid is being converted into a gas. I'm going to have a little break here. It takes, in the graph, it takes considerable amount of heat, more than we can show on our graph, to turn liquid water into a vapor. Eventually, when all of the liquid has been converted to a vapor, then the temperature of that vapor will increase as additional heat is added, taking us from 100 degrees to 110.